In the last lesson we studied self-inductance. Now in today's topic we study mutual inductance. Okay, the term mutual means it is related with one another. So we consider the two coils. Okay, it is mutual. So here we have considered the two coils. So this is first coil and this is my second coil. So let us name them. Okay, let the coil this be primary coil, okay, or simply coil number 1, and let this be secondary coil, or simply the coil number 2. I am using primary and secondary because it will be very easy whenever we do the transformer. Okay, so let the number of turns in the primary is N1 and the number of turns in the secondary be E2. Okay, in the primary coil what we have done is we have connected with a battery of EMF, okay, and with a tapping key, and here in the second coil we have connected the coil with the galvanometer. And please remember, these two coils are closely arranged, they are very close to each other, right? Okay, so in some other case what we can do is we'll couple them together, we'll bring it and we'll keep it here. Okay, we'll take one coil that is primary and we keep another coil on this, that will become secondary coil. In the same coil we can also wind one coil, and again we can wind another coil to study mutual inductance. Okay, coaxial, one and another in the same coil, but to understand easily we have considered it separately. Okay, very close, but they are very close. Now what happens is, let us tap this, let us tap it, and let us consider this as variable. So this EMF is increasing. Okay, increasing EMF. What is increasing EMF? That is, current is increasing. Let the current here be I1. The current here is I1, and the current is flowing in this direction. Why? Because current flows from positive to negative. Okay, so this is negative and this is positive, is flowing like this. Now whenever current is here, it will going inside, right? And it is coming outside towards us. From here it is going in. Okay, and this, here it is going in, and here it is coming out. Can you see this? Current going inside, coming outside, going inside, from here coming outside, from here going inside. So which is not required. And whenever there is current in this coil, what will happen? There will be a production of magnetic field. So let us have a magnetic field here like this. So this is the magnetic field produced in the primary coil, and there are so many magnetic field lines like this produced like this. Okay, so they are making complete loop, but I am just doing it like a half circles. Okay, so these all are magnetic fields, and a magnetic field is a vector quantity, it must have the direction. So what should be the direction? Now if you see here at the top, what is it? The current is going like this. Okay, if I see it from the top, it is going inside and it is coming outside. So it is moving like this. Is it a clockwise or anti-clockwise direction? It is moving like this. So this is a clockwise or anti-clockwise. This is anti-clockwise. If it is anti-clockwise, then it should act like a north pole. Okay. So we have studied this, why it should act like a north pole. Okay. So if you don't understand, please go to the previous lecture and then you will understand this. Okay. North pole and south pole can be easily determined in this fashion. For an example, if it is going in this circular loop and if it is moving in this direction, if the current is in this clockwise direction, okay, then this will be south pole. I will write it as south pole because it is also moving like this. Now if it is another term, if it is going in this direction like this, okay, it is moving in anti-clockwise, then I will write this as N, like this. The anti-clockwise, north pole. Clockwise, south pole. So like this we have done it. So it is anti-clockwise and north pole, and from north pole the magnetic field lines will come out. So this is how it is moving here. Okay, done. Now what happens is here the current is increasing. How does current increases? Let us study with the example. Okay, let this be time t and let this be current I, and 1 second, 2 second, 3 second, again 1 second, 1 ampere, 2 ampere, 3 ampere, and it is increasing like this. What does this mean? In 1 second of time there is increase of 1 ampere. In another 1 second there is increase of another 1 ampere. In another 1 second there is increase of again 1 ampere. So how does the current increasing? It is increasing by 1 ampere per second. This is how it is increasing. Okay. Now whenever there is increasing current, then there will be change in magnetic flux. Okay, there is flux change. Linked with coil 2. Isn't it? There is increasing magnetic field because of there is increasing current, and whenever there is increasing current, the magnetic field will increase, and whenever the magnetic field increases, the magnetic flux will increase, and this increasing magnetic flux is linked with the secondary coil or the coil number 2. Now whenever there is change in magnetic flux linked with any coil, the Faraday says that there will be induced EMF and induced current. Therefore, there will be production of induced EMF in the secondary coil due to change in the magnetic flux linked with the coil due to coil number 1. This magnetic flux is because of the coil number 1. Okay, so this entire phenomena is known as mutual induction. So let us mutual inductance, not the mutual induction. Mutual induction is the noun and mutual inductance is verb. Okay. So let us define what is mutual inductance. I will not write, I will just give you the definition. The definition is when we bring the two coils close to each other. When we bring two coils close to each other and apply some changing current to the one of the coil, apply some changing current to one of the coil, then the magnetic flux try to link with the another coil. Then the magnetic flux due to this coil try to link with the another coil, and because of this changing magnetic flux there will be production of EMF in the second coil. Okay, in the second coil this phenomenon is called mutual inductance. So what we say is due to mutual inductance there is EMF in primary or secondary? Yes, secondary coil, and because of this EMF there will be current in secondary, and this current I will write this as I2, and which is actually induced current. Okay, induced current. Which current is this? Induced current. Okay, so now let us see how much is the flux. Okay, let us see the theory. So let us find the flux. Okay, so this is flux, but I will have to give some name. Okay, let us find the flux. Flux link with coil 2 due to coil 1. Isn't it? The flux is linked with the coil number 1 because of the coil number, sorry, flux is linked with the coil number 2 because of the coil number 1. Okay, and I forgot to tell you what the galvanometer is. You know, whenever there is a changing magnetic flux in this coil, there will be EMF, and if there is EMF, then there will be current, and if there is current, then this will reflect. Okay, this indicates that deflection of galvanometer indicates there is current. Okay, so I am finding flux linked with coil number 2 due to coil number 1. So let us find this flux phi is linked with coil number 2 due to coil number 1 is directly proportional to current in this. Understood or not? this flux phi is linked with the coil number 2. This phi is linked with the coil number 2 because of the coil number 1. That is why we write the terminology is phi 2 1. Phi 2 1 is the flux linked with the coil number 2 because of the coil number 1. Fine. And I1 is what? The current in the coil number 1. If there is more I1, there will be more flux. If there is 1 ampere of current, there will be some amount of flux linked with the secondary coil. Now if there is 5 ampere of current, I1 is 5, it is more, then the flux will be more. If it is 10 ampere, then the flux will be more. Okay, so it is directly proportional. You know this. So here, if I1 increases, then phi 2 1 also increases. They are directly proportional, right? So there is one problem with this equation. The problem is that there is my proportional symbol and I want to remove it. To remove the proportional symbol, what we do is we put some constant. So let us do it. Let us see what that constant is. So this phi 2 1 now becomes equal, adding some constant m to 1 and I1. Very interestingly, I will name this at equation number 1. What is M21 then? What is M21? M21 is mutual inductance of the two coupled coil system. M21 is mutual inductance of two coupled coil system. Okay, right. Okay. So what could be the unit of this mutual inductance? Okay, before that, what is the unit of self-inductance? It was Henry. Similarly, the unit of mutual inductance is also Henry. We are going to define it later. Okay, so this is done. So this is how we have done M21. Why this is M21? Because this is linked with the coil number 2 because of the coil number 1. Again, same thing as that of phi. Now let us find the equation of EMF. How much EMF is produced in this primary or secondary coil because of the mutual inductance? Okay, so the topic is EMF in secondary coil. Produced in secondary coil or coil number 2. Okay, we know that EMF is equal to minus N. Okay, d phi by dt. Okay, this is the definition. Okay, let's say let N is equal to 1. For simplicity, okay, we have put N equals to N2, no problem, but for simplicity, let us consider N equals to N. Okay, not like here. Leave it. Okay, then I will write, I want to find the EMF in the secondary coil here, and this EMF will be E2 produced in the secondary coil due to coil number 1. Again, same, very simple. So I will write phi 2 1 is equal to minus of N2. Why N2? Because this EMF is produced in N2 coils. Okay, it is produced in the secondary coil in which there are N2 number of turns, right? N2, and there is d phi by dt. If this is EMF produced on 2 due to 1, then this should be also phi 2 1. Simple. Okay, let us put the value. Now, or I will write EMF 2 1 is equal to minus. This minus has come from the Lenz's law. Okay, of course you know it. And I will leave N2 here. ddt of, what is phi 2 1? This is M 2 1 I1 for N2 equal to 1. Khalas. Okay, we have considered the N2 here to be 1 just for the simplicity so that I can neglect N2. Here is 1 because I have taken N2 equal to 1. Okay, let me go to one more step, then we'll end this topic, right? Or I will just write this E to 1 is equal to minus, what is M to 1 is a constant, which is mutual inductance, and this is di1 by dt. So this is the equation of equation of EMF produced in the secondary coil due to mutual inductance. Okay, Now let us find the equation of M21. Okay, equation of mutual inductance. Let us finish this equation of mutual inductance, that is M21. How do I find this? What I do is, this is E21 is there, and I will bring this whole system down. di1 by dt will be equal to M21, and I will put the minus here. In general, what do I get? M21 is equal to E21 whole divided by di1 by dt. Neglecting the negative sign, or put it negative sign. Okay, let me not put the negative sign. This negative sign is only from Lenz's law. So we got the flux, we got the EMF, we got the mutual inductance. So this is all about it. Now let us go to the SI unit of mutual inductance. Okay, so I will write it here. SI unit. What is SI unit of mutual inductance? SI unit is Henry. Henry capital H. SI unit of mutual inductance is Henry as that of self-inductance. There is one more another SI unit. We will derive it. We know that, okay, from here. What do we get from here? Another SI unit. Sometimes it is asked in examination, that is why I am asking. So what do I get? See, M21 divided by I1 will be equal to M21. Sorry, this is phi to 1. This is phi to 1. I will bring this I1 here and I put this. Okay. So what is SI unit of flux? SI unit of flux is Tesla meter square divided by what is SI unit of current is ampere, or this can be written as Tesla meter square per ampere is another SI unit. Tesla meter square per ampere is another SI unit. What is the SI? What is that physical quantity whose SI unit is Tesla meter square per ampere? Don't think that how does this has come Tesla meter square? Why? From where? It has come from this equation. We know phi is equal to B into A. Okay? B is magnetic field, the Tesla is its unit, and A is the area, and meter square is the unit of area. Okay? This is how it has come. It's very simple in fact. Okay. Now define 100. Okay? The last topic is definition of 100. Whenever EMF becomes 1, okay? Whenever EMF is equal to 1 and di1 by dt is equal to 1 by 1 divided by 1. I is current, ampere, t is time second, that is 1 ampere per second. Then the inductance, mutual inductance is 1 ampere. Okay, let us find the definition. When it becomes 1, this will become 1 when this is equal to 1, and when this is equal to 1, then it will become 1 ampere. In fact, this is 1 ampere. Okay, it's very bored today. Anyways, let us define. When the EMF of, sorry, this is volt. When the EMF of 1 volt is produced in the secondary coil due to changing current in primary coil by 1 ampere per second. By 1 ampere per 1 second. This is the phenomenon. In 1 second, 1 ampere. Another 1 second, 1 ampere. Okay? When there is generation of 1 volt of EMF in the secondary coil due to change in current in the primary coil by how much change? By 1 ampere per 1 second. In that situation, the mutual inductance is said to be 100. Okay, so this is all about the mutual inductance. With this, we complete this chapter electromagnetic induction only for the 2021 examination, because in 2021 examination there is no AC generator. Otherwise there would be one more lection on AC generator. So thank you. Jai Hind.